Hey,
Hey,
Brian, welcome. Nice to see you.
thanks, you too.
So I think we'll actually have a pretty good turnout for this one. I am recording, just so you're all aware, and I should make a note of that on the announcement here, just so that I don't lose track of that. So everybody knows as they come in. Okay, and you set up the question, so fire away.
All right. Well, I thought about a few things today that I was hoping to get figured out.
Okay.
One of these is about like financial stuff because I'm still not aware of the differences between what stuff is like covered in grad school, what stuff typically do you still have to pay for, and
Right.
how that kind of works. And then some stuff about resumes and CVs, like things to leave on or off. And
Okay.
then just like the general schedule for like how all this gets done. Like, I
Sure.
mean, I've been talking to a guy and we've been emailing, but I haven't sent in applications yet. So
Yeah.
any of these things.
Okay. So let me start with the financial end of things. I've certainly known some grad students to pay their own way, but by and large, the advice that I got when I was applying to grad school was you should probably expect to be covered, either by TA monies or through research grants.
Okay.
Um, Now, that doesn't mean you're going to make any money, but you should
Right.
basically break even.
Okay.
Basically, it should cover cost of living and tuition and expense, the basic expenses of going to grad school. If you get an internship with an oil company or something like that, you might well make some money, but that's over and beyond the grad school experience. Um, and actually, I guess the advice that I was given, and this may or may not apply to you, but was basically, if you don't get financial assistance of some sort, it probably means they're not that keen on having you there. So that would be a consideration if you really want to work with somebody in particular, and they just don't have the money, but you really want to work with them. That would be a situation where you might want to pay your own way. But by and large, most programs, they should be able to come up with money either as RA funds or through TAing, one way or another, like that, grant funding. Does that sound reasonable to you?
Yeah, that's kind of what I'd heard. So, and I think also do like loans I've taken out. Do they kind of go on hold while you're in grad school?
They
Or?
should go on hold while you're in grad school. Certainly, that was my experience. In fact, they don't start kicking in until after you're graduated. There may be paperwork for you to fill out, but my recollection was you just had to let them basically establish that you were in school still, and everything was on hold. I don't remember the specific type of loan that I had, but I think that should be a generally across the board sort of thing. Morning, Kath. How are you?
Morning. I'm
Uh,
very well, and yourself?
I'm doing fine. Did you see the topic for today?
Yes, helping undergrads think about postgrad.
Yes, good. So you are in the graduate school position now, right?
Well,
Or
I'm
no, you're
technically just,
working.
yeah, I'm working.
Right. Yeah.
So
Okay. So
I've just finished grad school, essentially.
okay, great. So you've been through this process, so that helps.
Yeah.
By the way,
But,
I should say, Kath, before I go any further, I didn't even realize last time we were on this, was that last Thursday or last Monday, that the new geoblog was yours. I didn't realize that
oh, right.
until after
Oh,
we got off. So
oh, no worries.
glad to see that you're vlogging now. So
Thank
um,
you.
feel free to pitch it a little bit more later on.
Okay.
Um,
Oh, gosh.
um, so Brian, back to you. What was your second question there?
Um, well, I guess we can talk about like the schedule for grad school. I mean, I've started talking to a guy. I'm probably going to be emailing a few more here, just kind of letting him know that I'm interested and I've looked at his research. And
That's a great
like
start.
he's emailed back, said that, you know, like he told me a couple of the things he has going on, and just a little bit about some of his projects and that he wants to keep in touch. So I guess, you know, where do we go from there?
So I guess the question would be, are you a junior or a senior right now?
I'm a senior.
Okay, then my guess is you probably want to be getting on the application path pretty soon. Some schools will have deadlines, some schools will have rolling deadlines, some schools just take applications whenever. I know that some of the deadlines for entry next fall will be either right around now or maybe just past or still coming up. Usually there's financial aid deadlines around April 15th, and that's usually when you're making decisions. So basically this is the time of year that I think a lot of grad schools are really, having finished the fall semester, really beginning to look at applications. So I don't know about, you know, any specific school that you may be looking at. So, you know, talk with that professor specifically to see what their schedule is. It does depend a lot on the school. Like at Fort Hays, where I was teaching most recently, there was hardly any sort of a deadline. It was all really just very open-ended. There was no real specific deadline. At Wisconsin, where I did my graduate work, I think there was a fairly solid deadline, at least as far as getting applications in. Now, there are probably ways in most situations around those deadlines if you're you know, just getting started. But so I don't know the answer across the board there, but that's kind of the general rule. What I was told, so my experience on this was actually a pretty good one. I went to Colgate University for my undergrad, and our professors there knew that a lot of us were going to be going on to grad school, and were certainly keen to get a lot of us into grad school. And so they actually sat us down as kind of a group in our junior year, kind of midway through junior year, and laid out, here's your path to grad school. It's really kind of exactly the talk here that you're maybe looking for. And that's the only place I've ever been that's actually done that.
Yeah.
So it's definitely not the norm, but it was a really useful experience for me.
Yeah.
So what they laid out was basically start with, you know, getting GREs taken. That's certainly one of those things that actually has a deadline that you want to start thinking about. GRE, graduate record exam, if you don't know it already. And it's the general GREs, not subject GREs. GREs are different now than when I took them, so I don't know specifically how that's going to work for you. But our profs recommended that you take them once, either, end of junior year or very beginning of senior year, ideally. And that would give you an opportunity to take it a second time, maybe midway through senior year. And the thought there was just like an SAT, maybe the first time around you're a little nervous, you don't know how you're going to do. So, take it a second time and they count your best grade. So that's something to think about. Now, if you haven't taken that yet, you probably want to take it soon because most schools are going to require a GRE exam for admission.
Yeah.
Certainly it's one of those things they use to gauge financial. So that's another thing to think about. But it sounds like you're already talking with the professor, and that's actually one of the other things they recommended to us. So the GREs were one thing. And then just going out and, at the time, when I was an undergrad, we didn't really have the web. It was very, email was in its infancy. So I'm that old. These days, you can go out and surf websites, look for professors who are doing research that's interesting to you, and that's exactly what I would do, starting in junior year, but moving on into senior year, and then making contact with them is the next thing. If you find somebody who's doing things that are interesting to you, by all means, make contact with them. Tell them that you're interested. Ideally, go ahead and read some of their research papers, and if you can have a conversation with a faculty member based on their actual research, you'll probably get their attention even better. And then the application process, the basic way that it was rolled out for me was that, the kind of, and this is more for the bigger schools, the bigger research-oriented institutions. It may be different for other institutions, but for those schools, they were kind of looking at a first cut for a 3-part GREs, general GRE scores, undergrad overall GPA, and letters of recommendation were going to be the 3 things that they were going to be looking at. If they got a big stack of applications, they're going to kind of give each of those 3 things a grade and kind of rank the stack based on those overall grades. Then, above some cutoff point, they're going to distribute those applications all around to the faculty members. The faculty members are going to look at those applications and say, is this person even interested in the stuff that I do? If so, then they would, indicate something and say, yeah, I'm interested. I potentially could, work as this person's advisor. And that's when they would get back to you, or that's how the process would move along. If you've already made contact with a professor, that's going to get your foot in the door. And even if you don't necessarily have the GRE scores or the GPA or something like that, if you got really good letters of recommendation, this is where you can be pulled from the bottom of the stack and put up toward the top of the stack. So that's another thing to keep in mind. Beyond that, it's really a question of do they have the ability to support you? Do they have the interest in supporting you? And that's pretty much the process as I understood it as a student going through the process. So does that help?
Yeah, that answers a lot of questions.
Okay. Do you want to follow up on any of that, or anybody else want to chime in with a question or a comment? I don't need to dominate this discussion. We got enough to hear.
Hey, Ron, I've got a thought about interacting with potential advisors.
Mm-hmm. Go ahead. And this is David, speaking, correct? Just for the recording's sake, identify yourself when you're talking. David? I thought that was David. Well, I didn't mean to cut him off. We may have a weak connection there. Anybody else have any thoughts?
In the chat's comments, there's a question coming.
Yeah, sure. Okay, go. Michael, go ahead. Ask your question.
Hi, this is Michael McLaughlin from Denver, Colorado speaking. And I'm not a grad school student. And maybe you recognize my voice from a question I raised last week on Google+.
Indeed.
And I remembered your kind invite to join your Google Plus chat. But I don't want to interfere with your main purpose, so I'm happy to defer my question until such time as everyone else's questions get answered regarding grad school. I already went to grad school, but it's not in geology. So
okay. Any more geology grad school questions from any of you, or comments or thoughts on grad school?
Well, if anyone's interested in being more adventurous and going further afield, you can check out University of Cape Town, which is where I went to grad school. Mm-hmm. The process is a lot simpler to get to do. You don't have to do tests and things like that, or you didn't. And And as far as I know, they do need grad students. So you can email the professors there, see what fields they've got, and if you're interested in what they're doing, see if they can fund you. But yeah, it's a fascinating, beautiful place to go. The only thing is you can't go straight into a PhD. You have to do a master's beforehand, but you do have the option of upgrading from a master's to a PhD if you want to. So.
Yeah, I think that's another thing worth saying. There are some institutions that will let you jump right into a PhD program. Others that ask you to do a master's first. And in general, any one of these programs is going to want you to show progress equivalent to a master's before getting fully tracked into the PhD option, I would say. And in some schools, if you go to like an Ivy League school or something like that, they have what's called a terminal master's, which is to say the booby prize if you don't get the PhD program. But that's not the norm.
I know Australia also lets you come straight in from undergrad into a PhD as well.
So, Kath, in your case, was the application process one of just applying to the professor specifically, or was there a general application to the department as well?
It was, I suppose, a bit of both, because in the way the system works in South Africa is you do a 3-year BSc and then a 1-year honours, and then you can go into masters and then PhD. And I went to my honours supervisor and said, "Hey, do you have a master's for me? I'd like to do a master's."
Okay.
And he said, "Well, I have this thing on the bush belt." And I said, "No, there's this graduate on the west coast." And we hashed out the details and then made the application to the university.
That sounds great.
Yeah.
I got to say, I think a lot of graduate advisors love it if a student actually has the initiative to have a project in mind. Because I think a lot of graduate advisors, they get students looking for projects, but they'd really love to see the initiative of you going out and saying, "I really want to study this."
Yeah.
Of course, it's got to be close enough to their field and hopefully something they get funded for, too.
Yeah. Fortunately, we're stable isotopes, so it can be applied to pretty much anything.
Yep, that works.
But if you apply because I was going straight from honours into a master's, it was a lot. Okay. Because I was going into my master's straight from honours, there was a lot less paperwork involved. If you're coming from outside of the university, you'd have to send in your academic transcripts and all of that spiel as well.
Yeah. I think, it's certainly a lot easier if you're already known to the folks, and certainly going from a bachelor's program right into a master's program, that works well in many cases. I think one other bit of advice that I got when I was an undergrad looking at grad schools was, never do all 3 degrees in the same place. Never do bachelor's, master's, PhD all in one place. You should always get out and kind of see the world and possibly even go out and do different places for all 3 of them. And I think that's certainly sound advice. Don't want to end up inbred academically.
Yes, yeah. That's why I didn't do my PhD there, because it's the same. They look at people who come with degrees from all of their degrees from the same university with a bit of suspicion.
Yeah. I'm sure if you got all 3 of your degrees from Caltech, well, that would probably be all right. But few of us are so fortunate. Any other grad school thoughts?
I just thought of something. I've heard of cases, at least from a professor at my school who just recently got hired. He said one of the schools he applied to, he got accepted into the department, but the school itself rejected his application. So I mean, like, that's probably uncommon, but it still happens, I guess, some places. Or
It can. My understanding would be generally, well, okay. So the experience that I had would suggest that you can be accepted by a grad program as long as there's at least one professor there who's willing to serve as your advisor. That doesn't mean you're necessarily going to get funding from them, but usually they have to have at least one person willing to serve as your advisor. I know that when I applied to grad schools, the first letter that I got back accepting me to grad school basically said, "Congratulations, you've been accepted to our graduate program, and these advisors," and it was an enumerated list of all willing to serve as your advisor. And when you get there on the ground, you don't have to choose immediately, but I think that they generally want you to do the first year. You might go there and impress somebody else, and they might be willing to serve as your advisor, but that was my experience. Now, funding notification comes often quite a bit later. And in fact, it may be just around April 15th or so, which is usually their cutoff for funding to find out whether you're going to get funding or not. I know that I had funding for like 2 of my schools that I applied to, and I was waiting on word about funding from the last school till right up before the deadline. In fact, I actually made a school visit, which was as much for them to feel me out as me to feel them out, and ended up not getting money from that school, which kind of made the decision for me. So even though I was accepted into their program, without the financial aid, it was it's like being a walk-on for a football team. There's some glory there if you're really dedicated to it. But.
Yeah. David's brought up a very good point in the comments, in the chat, about the relationship you have with your advisor. It's also one of the most important things. From the experiences that I've seen and had with people, it's having a good relationship with your advisor is as important as what you're researching. Because if you have a bad relationship with your supervisor, it makes the entire process horrible, even if you enjoy what you're studying.
Yeah, that's absolutely critical. I would also add, if you're applying to different programs, you should always make a school visit before you decide to accept. And when you make that visit to the school, usually they'll put you up with a graduate student, which could mean you're sleeping on their floor, or they might have really cushy. It might be really nice. I remember making pancakes for one of the students that came to visit and stayed with me. He was very impressed by that.
Nice.
But you should definitely talk to the grad students. I mean, you'll definitely talk to the faculty, but also get a feel from the grad students, because the faculty member, they've accepted you, they're probably real excited to have you there, but you'll find out pretty quickly from the grad students whether that is a good thing or not. I had one school visit where I was told flat out by one of the grad students on the way to or from the airport, I don't remember, that this guy that I was looking to work with had a very short temper, and he was known for his volcanic temper, and didn't get along with some of his students. Other students who I met with, said they got along with him okay. In fact, they almost came out and said, "You've probably heard that he has a really short temper, but I get along with him okay." Those sort of things should kind of raise red flags. Maybe you're okay with that. Maybe you can get along with that. But actually, I had one situation, that same situation, where basically, I think on the way back to the airport on my way out of there, the grad student basically said, "I don't think this guy's going to get tenure." And it turned out that that professor did not get tenure. So I was pretty well warned away from that professor before I left the campus visit. So yeah, it's definitely, it pays to go there, go on the ground, talk to the grad students, talk to the other faculty, get a feel for the situation, and not feel that you're necessarily tied down to be in that one place forever. I mean, if you don't have a good relationship with that advisor, that person's going to end up having to write letters of recommendation for you, and if they can't write a good letter of recommendation for you, you might be better off transferring somewhere else.
Okay.
And you know, it's not to say that it's you or the other person. It may just be a mismatch. You know, it might just be a personality clash, and you know, there's nothing wrong with that. They could be a great scientist. You could end up being a great scientist, and you just don't see eye to eye on how to proceed. Some faculty members are very controlling and want to guide every step you take. Others are very laissez-faire and will say, you know, well, you know, you've got to figure out for yourself how to do things. You've got to know what's going to work best for you and do your best to figure out, you know, how that's going to work best.
Okay. What about when in the process do you look into visiting, or who do you approach or talk to about that?
So usually that's going to be in kind of the spring of your senior year, spring break of senior year. May sound like a great time to go down to Cocoa Beach or something like that, but I spent basically spring break of my senior year flying to 3 different schools, looking at their grad programs, and then another weekend just before April 15th flying to another school. Basically, I had last weekend where I had 2 schools that I was kind of torn between, and I had, you know, an offer to go out there. Most often, they will invite you. Many schools have money to bring you out to visit. Not all of them will. Make sure you know ahead of time if you're going to visit whether they're going to reimburse you for cost of flights or not.
Okay.
But it's certainly worth making the visit even if you don't get full reimbursement for it, because exactly the sort of things like I just went through. You know, you can learn a lot by actually meeting people and talking to them. A little easier, you know, these days with things like, you know, video chat, you could actually have a discussion with some grad students or with faculty members. It's not the same as being on the ground and seeing them in person, but it definitely gives you a leg up that we didn't really have when I was applying.
Okay.
Anybody else? David, Nick, either of you guys have anything to... Funding. So David's got a question about funding there. We started this right at the top of the conversation with that, so let me just give a quick summary of what I had to say about that. I figure you should basically figure on breaking even going to graduate school. You should probably not rack up a lot of student debt going to school unless it's some school you absolutely want to be there and they absolutely have no money for you but are willing to take you. Usually if they don't have money, that probably means they're not really that interested in you. It could also mean that they just don't have a lot of money. They may be very interested in you but not have money. Again, I would expect to basically break even going to grad school, not to rack up a lot of savings. You know, you're kind of living in grad student poverty. But that was my experience. It pays when you're looking at grad schools to get a sense of, you know, how good are faculty members at getting funding, how much funding have they got. And one of the things you can do, certainly in the United States, is look at the National Science Foundation. They have, you know, on their website a whole database of all the funded grants. It's not the only place that you can get grant funding from, but certainly it's a good way to see. You know, you can type a search term into there and see who's gotten funding on some specific topic area or region that you're interested in. So, it might even be a good starting place to go looking for grad schools is figuring out who's got funding. Another thing to look at is how many other graduate students does one professor have? You might be looking at a situation where a professor's got a phenomenal research program, but they've also got 15 graduate students. And if you're going to be one of 15 graduate students, well, A, you're going to start pretty low on the pecking order, and B, it could be a real struggle for funding or just struggle to get their attention. If you're, really driven and able to be, self-starter, that might be okay for you. On the other hand, maybe you'd prefer to work with somebody who doesn't have any. On the other hand, if you got somebody who has no graduate students, maybe they're just getting started. Maybe they're, haven't had much funding success. Maybe they're just hard to get along with, or maybe none of that's true. Maybe they're perfectly good. So that's something, again, you want to kind of try and get a feel for ahead of time, but you might have to be on the ground to actually know that.
Okay.
Another thought there too, and it's slipped my mind. So. Yeah, again, the advisor decision is not one that you necessarily make first thing in there. In fact, I've known people who switch advisors. You might get there and decide, wow, this other person's doing something that you didn't really think about, and you'd really like to work with them. And be sensitive to politics when talking about working for one advisor or working with another advisor. A lot of these folks have egos. You want to be careful not to go bruising people's egos. And another thing to keep in mind when you're in that grad student position is that if you're getting money from one of these advisors through a research grant or something like that, that's not just money that they're giving you so that you can go to school and survive. There's an expectation that you're going to be aiding their research. The reason they were able to get that research money was because they had a proven track record of making publications out of it, or some promise of doing that. You're going to be involved in writing up some of those publications, and if you drop the ball, then you're not only hurting yourself, but potentially really, hurting this person's ability to get future grants. So this is something you don't always see from the undergrad going into this whole thing situation, but you have to be aware that it's competitive for grants, and faculty members have to make decisions not just based on how nice a personality you have, but also whether you're actually producing results, because it's a bottom line sort of business. It's going to seem pretty cutthroat when you get there into grad school, and just not necessarily in every situation, but be aware of that going in, because although it's not really made very obvious to most people, it is there, and you'll pick up on it eventually.
It's good to know.
Also, pay attention to politics, and I don't mean Democrat-Republican politics. I mean ego wars within departments, people that get along and don't get along, research groups. There are some schools where everybody gets along real happy and it's one big happy family, but those are few and far between. Very often you've got research programs that are not necessarily directly in conflict with each other, but they are a strong struggle for power within that department, and that can get, in the worst cases, to a point where you just got faculty members who will not talk to each other, if not being outright hostile toward each other. That's another one of those things that you won't really pick up on probably until you're there on the ground or have talked to somebody who's there. these don't have to be a problem for you, but you should be aware of them. And, before you start talking to, you got an advisor and you start talking to another person about doing a project over there, be sure you're not aggravating tensions between those two people, or be sure that they're all aware of what you're doing or what your interests are. Because in some situations that can be very bad. You don't want to burn bridges.
Right.
And again, I had a really great undergrad experience. We had a department that, on the surface anyway, to the undergrads, got along very well with each other. And so I had no experience of politics going into grad school, or at least none of that was visible to me as an undergrad student. And I had a pretty good graduate experience, and I really am not complaining about that. But it was after I went back to visit my undergrad institution, I got a little hint of the fact that there was, in fact, politics that was well hidden in that case. Usually in grad schools, it's not so well hidden. So you'll be experiencing it more firsthand. And again, it doesn't have to be the case. In some cases, everybody gets along just fine. But it's something to be sensitive to.
Okay.
Anybody else? Thoughts there? I'm not... another thing, while I'm thinking about it, as far as going into graduate school, is if you get a TA, teaching assistant sort of job, you're going to end up grading papers and things like that. And coming out of undergrad, you may think that's a very important thing for you to do. Spend a lot of time grading those papers, and grading jail. You've probably heard us tweet about things like this. I came from an undergrad experience where the teaching was very front and foremost, more so than the research, or at least it appeared that way. The research is generally what's driving the graduate institutions, and you got to find a balance between your teaching duties and your research duties. You cannot put all of your time into teaching duties at the expense of your research. This is one of these things that you have to learn that balance in that first year of graduate school. But this is a heads up that, the research is what drives the funding. The research is what drives your ability to get jobs. Don't lose track of the research.
Right. Yeah, this year I've actually had the opportunity to TA the intro class for 6 semesters now. And I've TA'd paleo and sedimentology. But this year in particular, I took on a lot of that. Like, I was doing 2 different classes of the intro and sedimentology, and I took on being the president of our club, and I was working in the planetarium. And I realized, I was taking on stuff because I was like, well, this will look good and it's income. But it had somewhat, like, not a big effect, but it was starting to overflow into my schoolwork somewhat.
Yeah, balancing those things that's a big part of the graduate school experience. You're going to find, there's an attrition rate. When you get into a big graduate program and you've got, 20 or 30 other people coming in at the same time as you do, you're going to find by the time you're graduating, only a third of them are left. Some of them couldn't hack the research. Some of them had families and other demands on their time. Some of them are going to do great. And you will find it probably different than your undergrad experience. And how you make that adjustment is a big part of, that experience, especially at the master's level. Usually by the time you're applying to a PhD program or getting into that, you've at least been through the ringer and you know what the drill is all about. There are indeed still other pressures when you go on through the PhD, but that transition from undergrad to graduate school is a big one, and not everybody makes it through. And it's not always based on just ability. A lot of it's based on how well you can spend your time, and how dedicated you are to this, because it's going to take a lot of your time. Graduate studenthood is, great for fraternizing and drinking beer and things like that, but also you're going to work hard as well as playing hard.
Yeah.
Also, yeah, you have to be quite self-motivated to get through as well, because if you're doing research, or if you're doing a master's or a PhD by dissertation, so pure research with no coursework, then you don't have those deadlines that are imposed on you to meet. You have to make your own deadlines, and then a lot of people struggle with that. I know people who are still doing masters 5 years on and things like that, so yeah, you have to be very self-disciplined.
And you may have, the opportunity to do some teaching as you get toward your PhD. And, you might have, thought, well, I want to end up in a teaching job. And, the research is mostly done, so if you can go on to the teaching, you still got to write that dissertation and, get that writing finished. And that takes a lot of self-discipline, because the advisor can have weekly meetings and stuff like that, but you've got to be motivated to get all the way through that. And that takes some fortitude. A lot of the master's and PhD experience is jumping through hoops. And, that's because a lot of the job beyond that is jumping through hoops. And, when you're applying for a teaching job, they want to know that you're successful at jumping through hoops. It's not always, who understands the geology the best, but who understands the geology well enough and can get through all the hoops and move onwards. It's a little bit more cutthroat than undergrad. Not to make it sound terrible.
Oh no, I'm still excited. Yeah,
it's a pretty good experience. I mean, especially if you get a good bunch of friends. I mean, some of your grad school friends are going to be some of your best friends, and probably colleagues too at some point in your life. So that's why I haven't been following all the comments that are on the side, but am I missing anything important? Criteria to enroll for the master's in the U.S. David, I have to say I'm a little bit hesitant to speak too authoritatively for your situation coming in from outside the U.S. I mean, within the U.S., the general expectation is that you've completed a bachelor's degree, which is usually 4 years of undergrad. And once you've completed that, really, again, doing the GREs, the undergrad GPA, and letters of recommendation from undergrad, teachers, advisors, or other people is generally what's going to get you into graduate school. The individual programs may have a specific group of courses that they want you to have covered. In many cases, if you're deficient in one course or two, that's not a problem, and you can make that up as part of the master's degree. So, for example, most schools will want you to have taken a field course at some point. Not everybody has that opportunity as an undergrad. So, in starting a master's degree, you might have to go back and take that kind of undergrad field course as part of that, just as a deficiency. As far as the 3-year bachelor's, I have no idea how that's going to translate, and it might be very different for different schools. I think probably what's going to happen is they're going to look at your transcript and see which courses have you taken, but I don't think 3-year bachelor's is necessarily a problem. I think it's a question of which courses do you have and which ones you might have to make up as a deficiency. So I would go ahead and apply even with the 3-year bachelor's, although I don't know exactly how that's going to transfer in any given situation. That's definitely a problem with Europe and the U.S. because we have whole different approaches to higher education, and I know that's well, not something that I've had a lot of direct experience with, so I can't say too much about it, but it does create issues. All right, so any other grad school questions, thoughts, comments? I know I've kind of dominated here. I was really hoping we'd have some other faculty members here. I had invitations out to a bunch of them. It looks like most of them are either still in grading jail on their own or are not yet able to master the technology to get online here. So congratulations to all you guys for making it in. You know, my advice, I certainly hope it's good advice, but you know, you shouldn't take one single bit of advice and use that as all your advice. In fact, there's a distinct possibility, because this is a really good topic, that we'll run another one of these things sometime in the spring semester. I really think there's probably a bunch more people that would like to hear about this. And certainly I would expect that, you know, based on the video that we're recording of this, other faculty may look at it and may say, oh, he's just full of baloney. You should really, you know, listen to this other advice. I don't know. Certainly it pays to get more than one person's advice.
I did have a seminar class my junior year about most of what we've talked about. It's just at this point, like when I was a junior, I wasn't thinking as much about it, and now that I'm a senior, I've kind of forgotten what all we went over. But this has refreshed a lot of what I'd heard, and you've said a lot of new things too that I didn't know. But it's been really helpful, so thanks.
Good. All right, Michael, you've been waiting patiently. Fire away with your questions.
It's going to be amateur hour because I have no training.
That's fine. You got a whole bunch of geologists here, so I don't have.
I know. I'm very pleased. Thank you. Well, my interest actually, I'm a finance administrator. I work for the University of Colorado Hospital, and I have an interest in astronomy. In fact, I met Pamela Gay from Astronomy Cast. I think we're in the same circle, Ron.
Okay.
So just to give you a little background, so just as an amateur, I read books and attend lectures and so forth, and I've been reading about supernova and the creation of heavier elements.
Yep.
And I was thinking about the fusing of electrons into neutrons and changing the properties of elements and creating heavy elements such as iron or gold, I think I mentioned as a. And I was wondering once these atoms or elements are created, assuming these theories are all correct, then they float in space for millennia and somehow get coalesced into a protoplanet, which eventually winds up here on Earth or any other planet, right? So I'm wondering how those elements, those like elements, are found together in seams and veins within the Earth's crust. Is it a process? Is the amalgamation happen in space, or is it a sedimentary process? Someone had mentioned sedimentary.
Yes.
There's a little vein there. So I was just wondering again, how do like elements find each other, so to speak, and then what attracts them that we can find them grouped together?
So that's a great geology question, and you just asked for about a semester's worth of answer.
I guess there's different theories.
Well, no. It's less that there are different theories. There's so much meat on that bone to describe that if I just get started on one aspect of it, it's gonna leave you short of a complete answer. Let me recommend one thing right off the bat. If you have access to it, Nova series. Neil deGrasse Tyson recorded these a couple of years ago. Episode 1, Earth is Born, is a great overview of the early history of the planet. Yeah, Nova Origins Earth is Born.
I met Neil deGrasse Tyson in 2001. He was doing a seminar on, or discussion on, Arthur C. Clarke's prediction in the films that were made versus reality. And I think this is before he was popular.
He's quite a speaker. So this is a series, the Origin series probably came out, 4 or 5 years ago at least now, maybe more than that. But I actually used that Earth is Born video in one of my early lectures in Intro Geology. Ever since I've had that, it's a really good description of basically from the supernova to the early formation of the Earth. And it takes you from the dust cloud, the cosmic dust cloud, and if I can, I'll try and do this in a nutshell here, but you got a cosmic dust cloud. Gravity acts on that. So you turn gravitational potential energy into kinetic energy. All that dust begins to come together. Most of it coalesces in our solar system in the sun, okay? But little bits of it get coalesced in the planetary bodies, and others of it is just dust floating around in the solar system. When that material comes together to form the Earth, all right, that portion of it that becomes the Earth, of course, all that kinetic energy is turned into basically thermal energy, all right? And that's where the heat, much of the heat from the planet comes from. There's radioactive decay as well, but over the course of the history of the solar system, that original heat of formation is a major portion of the heat that's driving all these geologic cycles. So initially, you imagine from that solar dust cloud and from the solar nebula and all that, you got a pretty well mixed. Certainly it's very chaotic. Everything's coming together. There may have been minerals in that dust cloud. I mean, there may be protoplanets or whatever that were out there prior to collision. There might have been some differentiation of those things, but in that original mixing, you got a pretty well, thoroughly homogeneously mixed planet. That's the assumption anyway. And certainly when the planet comes together, it's so hot that the outer couple hundred kilometers basically form a magma ocean initially. And that, of course, is extremely hot, liquid, so it mixes fairly thoroughly. And then, of course, it all begins to cool. There's still meteor bombardment, stuff like that, so this is not an instantaneous process. Although geologically, all that condensation, all that coming together happens pretty quickly, on the order of a few tens of millions of years, as opposed to the 4.5 billion years that it's been since that has happened. So it's almost a blink of an eye geologically that all that comes together. So, okay, now you got a big ball of material. Most of the gases, the light materials, get blasted out of the early solar system as the sun fires up. This is why we have predominantly these rocky planets on the inner solar system. So the more volatile stuff gets blasted away by and large. Now, we do have an oxygen-rich atmosphere. That oxygen had to stick around somehow. Most of that's because it was buried deeply within there, dissolved in the lavas, dissolved in the magmas and such early on. As you begin cooling down, you begin differentiating this planet. And the first big differentiation is that early on, the more dense materials sink toward the center. And specifically, that's the iron core. That's the core formation event that happens real early on. And basically what it is, it's like the unmixing of a vinegar and oil salad dressing, right? So vinegar and oil, you get your oil and your vinegar, and these are two liquids that when you shake them up, they are pretty thoroughly mixed. But as you allow them to settle, there's a density separation. And the oil, being less dense, floats to the top, and the vinegar, more dense, sinks toward the bottom. That's the core formation. And that's the first differentiation event. What's happening since that time is really a slow refinement of that outermost area, the mantle and crust of the Earth. The crust over the last 4.5 billion years has basically been distilled out of the mantle. All right, and the processes are melting and crystallization primarily. And in transferring from melts to, from solid rocks to melts and melts back to solids, different elements behave in different ways. Some elements in the mantle, when you begin melting the mantle, some elements separate out much more readily than others. Those tend to get concentrated. What's that?
Based upon density, for example?
Not really even density. I mean, you would.
Density.
So the density was important early on, and the density will be important in other processes, but in fact, it's actually crystalline incompatibilities in mineral structures. So the mantle of the Earth is dominantly the mineral olivine. It has a crystalline lattice. Within that crystalline lattice are about 3 or 4 different sites that are given dimensions, size, and charge, all right, and different chemical elements fit better or worse into that crystalline lattice. When you begin to melt the mantle and the other minerals that are in there, some chemical elements like potassium, for example, really big, highly low charge but large ion, does not fit well into any of these minerals. And so it begins to go off into the melt more readily. Uranium is another mineral. Now, uranium is a very dense, high specific gravity element, and you would tend to think it would sink. But in fact, because it's easily concentrated into the liquids, it actually ends up getting concentrated in the crust of the Earth. Because these liquids themselves are less dense than the surrounding mantle, and they will begin to rise into the crust. By the way, you know, as much detail as I'm giving you here, I'm oversimplifying a lot of things. So
thank you, appreciate it.
but this is the basic process by which the crust eventually begins to get distilled, and I use distilled as probably the best general term for this, but you're essentially pulling out the things that don't want to be in the mantle and concentrating them in the crust. And so this is how the crust basically gets separated as a lower density overall, and more concentrated in things like feldspars, aluminum-rich feldspars, silica quartz, and things like that. A lot of what happens beyond this is, still some magmatic processes. I know over Brian's, they're yelling Bones reaction series, and yes, that's a big part of how igneous rocks begin to differentiate as they come up, and that's a big part of this whole process. But later on, also water, is one of these things that's actually incompatible in the mantle and wants to come out to the surface. And water will dissolve chemical elements, some preferentially, and others that'll leave behind. And a lot of the veins and mineral deposits that we see are the result of magmatic water coming off of these intrusions and then interacting with the crust. And that's how we tend to get these more pure mineral assemblages, these veins of quartz with gold in it and things like that. So, yeah, that's kind of the answer to your question in a nutshell. Now, if you got more specific types of, how does this particular mineral form, I can answer that on a more case-by-case basis. But
no,
that's the blood answer.
No, I just needed a general understanding, and I will follow up with Mr. DeGrasse, excuse me, I guess it's Dr. DeGrasse.
Yeah, and actually that's really great for the early history of the Earth. It does not get into the crust formation. So, and again, a geology class is going to talk a lot about this crust formation. Water plays a big role on Earth. If you compare the Earth to Mars, for example, there's certainly water on Mars, but not nearly as much as we've got here on Earth, or at least it's not behaving in the same ways that we have it here on Earth. And as a result, well, at least as far as our general understanding, let's take the moon. The moon is maybe even a better example. There is certainly some water on the moon, but a lot less than here on Earth. The moon, by and large, is pretty undifferentiated. There are the lunar highlands, which are north of the site. There are the lunar maria, which are largely basalts, but most of the moon is the average composition of, say, the oceans of the Earth, about the same composition, broadly speaking. The continents that we have on Earth are really a distilled process that happened because of the abundance of water on Earth. And so the processes, the igneous processes, the metamorphic processes that are involved in subduction and mid-ocean spreading, that's really distilling the crust even further and producing continental crust as distinct from oceanic crust. And then within the continental crust, you get, individual plutons and veins and what have you. And the oceanic crust does this to a lesser degree, but also has some of the same processes working.
Okay. Well, thank you for the time and the information. Much appreciated.
Yeah. Anybody want to contradict me or tell me I'm full of? I mean, that's certainly what I've been teaching classes for many semesters, and again, it is an oversimplification of the whole thing. But I mean, you ask a great question. That is a pretty fundamental sort of question. Is how do we end up with individual rocks and minerals that are different from each other? How do we get ore deposits? I mean, it's a fundamental question of society, and it is what geologists study. Not just to make money, but also to understand the planet. And hopefully other planets when we get out there to study them.
Are there courses in comparative planetology? Is that the right word? I'm not sure. We're looking at the geography of Mars
it's
and the
great.
moon.
It would be a lovely thing, and I would say that any course that would cover that would be necessarily speculative to a large degree at this point.
Right. One day.
Not that it wouldn't be a worthy subject of study, but we actually have material from the Earth. We have direct return material from the Moon via the Apollo program, and I think the Russians had a robotic mission that brought back lunar material.
Luna. Yeah.
We have
almost had a focus.
We have the rovers on Mars who are doing analyses there, but we haven't returned any material from Mars. Although we do have Martian meteorites. And, we've got meteorites from throughout the solar system, throughout the inner solar system anyway, that they give us some clue as to what else is out there. But, yeah, to do comparative planetology, it would be a lovely course to have, and I'd love to take it. But we're fairly limited in the number of samples. Well, we got to understand this planet first, and there's a lot of diversity on this planet to understand that we actually have a chance to really understand a lot better. But yeah, if we get a chance to get manned missions to Mars, or even just robot return missions where we actually get more stuff to sample, or frankly, I mean, the rovers are doing spectacular geology, and we're learning a hell of a lot from them. It's just not the same though as being able to kick that rock. Ooh, what's that one?
Right. Good stuff.
Mm-hmm.
Maybe not at this session, but maybe some future session we might talk about how we know that the rocks that were picked up, I guess, in Antarctica are indeed from Mars versus the Earth. There must be some sort of isotope that's.
Yeah.
I don't want to.
No, that is you've got it there. It's stable isotopes is ultimately the answer to that one. And that was one of the first things that when I first heard this Martian meteorite being analyzed for possible signs of life, how could they know it's a Martian meteorite? And it turns out, again, I'll give you the short answer because I've heard it. The Viking expeditions, when they went to Mars back in 1970s, they had stable isotope mass spectrometers on there, and they were able to analyze the, I think it's oxygen isotope ratios. And basically they found a distinct oxygen isotope ratio on Mars compared to what you'd see on Earth. And it may be more than just oxygen isotopes, but it was some sort of stable isotope measurement. And basically what's happened is they've analyzed these Martian meteorites, and they found the identical stable isotope ratio to Mars. And that's the basis for calling it a Martian meteorite.
And there was not a reasonable chance of finding the similar isotope on a typical Earth rock that has the same isotope ratio?
I guess the range of isotope ratios that you see on Earth is somewhat more limited. I don't know the specific numbers. Kath, you seem to have worked with stable isotopes. Answer that one better than I can.
I think it has something to do with the abundance of the different isotopes. So I suspect because on Earth you have a set abundance. Because you're dealing with stable isotopes, they don't form by radioactive decay and they don't decay. So the relative abundances, the ratios between them don't change. So you'll always have 99.99% of your oxygen will be oxygen 16. And I think the Martian ratios between I think it's oxygen 17 and oxygen 16 is very different to the ratios that you get with oxygen on Earth. And I think that's one method that they went through to look at that.
That sounds right, and that begs the question, how do we get different ratios on Mars versus the Earth? And what is the entire range of Martian versus Earth, and is there overlap? And that's, I mean, those are good questions to be asking as a scientist, and I'm not enough of an expert on stable isotopes to answer those. But yeah, basically it was a match on stable isotopes that made it much more likely that it's Martian than Earth origin.
Okay. I got a million questions.
Well, that's okay. I indicated in my blog post, I don't know if you all saw that I'm going to take about 2 weeks off for the holidays now. So my next Geology Office Hours hangout will likely be, I think it's January 5th is the Thursday after New Year's. If there's some big event in the news geologically, or if one of you has just got a question you're dying to know the answer to that has to be answered through a hangout, I could probably have another ad hoc one, but I just figure we'll take a little break here and then start fresh in the new year. But I definitely intend to continue doing these in the future. So
great. And you take amateur questions too?
That's what it was aimed for. Well, I mean, that and any questions that can. It's held for the public, and I expect whatever sort of questions come in. I don't think I've had anybody yet come in saying, "Hey, is this a meteorite?" But that's going to come eventually. I'm going to say, get a magnet, see if it sticks.
Well, all right. Well, I think I'll go back to, this is the first time I logged into Google Hangout at my office. I'm really surprised my employer allows me to do this. I brought my laptop just in case.
Well, I'm glad your employer does, and I
So, yeah,
more
well,
know that, but
I'm sure they're going to shut down this whole.
well,
Yeah.
Hopefully you've learned enough to make this actually a valuable thing. Working in an academic environment, shouldn't they be encouraging free speech here?
They should.
You're not giving me medical secrets or anything like that, so.
No, not at all. No, that's great. We had Skype for a while. That got shut down, and imagine all the other social things. So this is new enough that they haven't plugged up all the ports yet.
I hope that's a situation where it was maybe a burden on the network and that they had to shut down, but as the network gets better, they'll revisit that. But I know that's not always going to be the case. I'm doing this from home, so nobody shut me down.
Great. All right, well, thanks again, everybody, and thank you for sticking around. Appreciate it.
Sure, a pleasure.
Okay. All right, I'll be signing off, and goodbye,
Sure.
everybody.
Any other questions? Anybody else? All right, if not, we'll call it a week. This one was recorded. If anybody has any objections to me posting this thing, speak now or forever hold your peace. All right, well, I'll sign off then, and we'll see you all in the new year.
Have a good
happy holidays to everybody. Yeah.
Okay.
Take it easy.
Thanks, everybody.
Bye.
Cool, thanks. Ciao.
Bye.